everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing linked list topic. The pattern was merge and sort, and today we will solve the next question, which is remove duplicates from sorted list. So let's read the problem statement. The problem itself says that it will be a sorted linked list. Note it down because this will help us in optimizing our code. And it's asking to delete all duplicates such that the element appears only once. Okay, and we have to return the linked list in a sorted way as well. So the question says that we will be given a linked list. We have to remove our duplicates here. It is sorted, and after removal also it should be sorted. Let's read the constraint. Constraint says the number of nodes can be 0 also until 300. See, 0 means we have to check for the base case. If head does not exist, it does not mean of removing the duplicates, right? The number of nodes are 300 because obviously this will be a linear solution. You know, mostly in linked list we do linear solution, so we don't need to worry about the TLE for sure, but we have to optimize our code. Let's see how can we optimize it, but before that let's see how can we do it with a brute force approach also. So the question says we'll be given a sorted linked list. Definitely when the question explicitly mentions it will be sorted, it does mean. But without optimized, how can we think in the brute force and layman language? So the thing is, the question says it will be in sorted linked list, but what if we had list? We had list. How we could have removed it? Means one idea is add in the set 1, 2, 3. So it will have only unique elements and then create the new linked list. But the thing is, see, set does not maintain the values in the ordered, right? It will not in the same order. So set might have saved like this. So if you will create the list now with these values, so the new linked list will become 2, 1 and 3. So the other way is you have to sort it. But why to do that when the question itself mentioned it sorted? So set we should not use. Now next what? Don't you think if in the linked list only we can do like that? How? The very first value current will point here. Can I say that? And the very first value we will save it here. When our list was empty. Now when our current moves on this, now the list is not empty. So what we will do, current dot value and list which value? Last index value. If both are same, means for sure current is holding a duplicate value. So just move the current ahead and don't add this value in the list. Done. We will not add. So now what we will do? We will move the current ahead at 2. Now again, current dot value 2, does it matches this with list dot last index? So for last, how can we do that? We will say list dot get last element means list dot size minus 1 last index. If this is same with current dot value, don't add. Means if this is not same, then only add. So what we will do, if this is not same in our list, we will add what? Current dot value. Very simple. Correct? Yes. So now we will add 2. So let's add 2 here and we will move our current ahead. So current will point to 3 now. Similarly, last element 3 does not match. So we will again put this 3 here. Now what we will do? We will move this current ahead and now it will say, hey, current dot value and last value matches. So don't add anything. Don't add anything in the list. Just move your current ahead. Means for sure if case runs or not, current is going to move ahead. Current dot next. Can I say that? Yes. But until when? Can I say that this will keep running until my current becomes null? Yes. So in the while loop, what condition we have to write? While our current not null, keep doing this. Done. Now this line of code will help us to create the linked list in the same sorted order by removal of duplicates. So now our linked list, now our list will have 1, 2 and 3. And now what's the task? We have to create the linked list out of it. So create the new linked list with these values and return the new head. Very simple. Or else if you want to optimize it better, just override these values here. But remember, the number of nodes are greater here than this. So how you will do now? override, override, override. Once done, like override will have over means list, you are out of index, then whatever its next value, just connect it with this null and return this head. Very simple. So can we write the code for this? So here is the code we have discussed. First, the base case, if our head is null, we have to return null then and there, or else we will create a new list and a new alias named current. Now until our current becomes null, we'll keep on checking. If our list last value does not matches with current, it means we have to insert that value in the list. So we will just add the list. Okay. Now the thing is, what if the linked list, like what if we are going to insert the very first value in the list? Then we have nothing to compare in the list. So in that case, we have to write this base case, if our list is empty or this condition. So for the very first condition will run and it will add in the list. Now the thing is, if case runs or not, we have to move our current at current.next, correct? Why? Because we have to check every numbers if they are duplicate or not. Now after these 3 lines of code, we are ready with our list with unique values and that too in sorted order. Now the task is we have to override those values in the original linked list. So we'll again start our current and we will run the for loop until the size. Why? Because I just showed you that this size will be definitely greater, but we have to put values as per this size. So that's why we will run the for loop for the list size and we will override the values in the original linked list. So we'll run the for loop. Now current.value we will override with list.getI. Now these line if and else is for the condition if our current I is pointing to the last index. If it is pointing to the last index, so after overriding, just connect its next to null. Why? Because see, this is the last index, means can I say 0, 1, 2? So for 0 it will override 1, for 1 index it will override 2, for 2 index it will override 3. So is this index is the last index? Yes it is. Then it's next we should connect with null, correct? Or else if it's not last index, then it's next we have to just move our current at current.next. That's what we were doing. If it is last index, connect current.next to null, or else just keep moving ahead. And at the end we have to return the original head. So in this case, the extra space complexity was only taken by the list. But the time complexity is first O of n for this, correct, to put in the list, and further O of n, nearby O of n only to override. Why I said this? Because for the best case, there might be the case we have all duplicate elements, correct? Then the for loop will run for only one time. But what if for the worst case? Worst case means suppose we have no duplicate elements. Then what will happen? These many, like this while loop will end up inserting every unique values in the list. Now this line for loop will also run for the size of list, means O of n. So O of 2n time complexity and O of n space. Why? Because we are making the list here. Okay. So how can we think for the optimized code? Let's see. Because the question itself mentions that it is sorted order, correct? And can we do this without space complexity? That is the main concern in the linked list, okay? And that's called in place linked list. So idea is very simple. Currently we are at here, okay? So can we say, let's say it current, okay? Head to it is there for sure. This is head, but let's say this is current, okay? Now what do you think? This needs to be compared with this current and current.next. Can I say? Why? Because then only we can say na ki it's duplicate or unique by checking the values. So for it, for sure, our current means while our current not null as well as current dot next not null. Done. Now what we have to do? We have to check if our current value and current dot next value, if it matches, then we have to delete this. Delete this means very simple, connect this next to this and done. Yes. So what we have to do? Ki if our current dot value equal to current dot next dot value, if they are same, then just we have to connect current dot next to where? Current dot next, and that's what we have to do. So can I say this will get connected with this, correct? Or else we will write if the condition comes. Done. Now what will happen? What will happen? This, like current we have not moved, but we have disconnected and connected to its next. Now again it will go While my current not null, yes, current not null, and current dot next not null, yes, 2 is also not null. So now again, if my current dot value 1 matches with this, no, it does not matches. So now what do you think? What should happen? Definitely, if it does not matches, then this much is clear. So we have to move our current to this, saying going forward, what if we have duplicate values? So now what will happen? We have to move our current to current dot next, correct? So here simply we will move our current to current dot next. Done. Now again what will happen? Again we will go in the while loop. While current not null, yes, it's not null. Current dot next not null, yes, it's not null. Are their values same? No, it's not same. So move your current to current dot next. Why? Because we have nothing which is duplicate with 2. So we will move ahead. Again we will go in the same while loop. Current not null? No, it's not null. Current dot next not null? No, it's not null. Is current value and current dot next value same? Yes. Yes, it is same. Now what to do? Current dot next connect with its next dot next. So we will write current dot next to its next. So can I disconnect this and connect its next to null? Again we will go here. While my current not null? Yes, current not null. And current dot next not null? No. It's still null. So with this while loop will break. So what is the linked list? We have 1, then 2, then 3 and then null. And that's what we wanted, right? So we have removed everything. So at the end we have to just return our head. So after coming out of this while loop, we will just return our head. And that's it. So what's the space complexity? We have not created any space. So space complexity is constant and time complexity is O of n. Why? Because we have only iterated for one time. So this is the best and optimized code for this solution. So can we write the code? So this is the code we just discussed. Make a alias, keep moving until current and current dot next not null. And if both are same, values are same, then disconnect and connect to its next, or else just keep moving and at the end return the same head. So when we will run and when we will submit this code, you will see that this is the faster code also, because space it's constant and time it's linear. So this was your Java code, and with the similar approach here is your C++ code if in case you are from C++ background, and here is the code in Python with the similar logic if in case you are from Python background. So if you understood this code, definitely we can go in the sheet and mark the second question as done. And expecting you all would have done on your own and prepared your notes also for your future revision. And that's it. If you have any doubt, please reach out to me. Please mention it in the comment section. And it's a humble request. If you really like the video and the pattern wise DSA, then please do recommend subscribing the channel and liking the video as well. And that's it for this video. You will get the link of the sheet and my social medias to connect in the description. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family too.